Good afternoon, everyone. How are you?
Good afternoon.
This is not your class. You're not here. Okay. All right, guys. Last time, guys, we talked about some concept of machine learning, and actually we covered three part of this concept. We talk about what the first one talk about why we need machine learning, correct? Why do we need machine learning? And we agree, guys, for some specific specific problems, we cannot write a program that solves this problem because we don't know how we think about it, like recognize facing. How we recognize, I recognize all your faces now. Okay. What a program in my mind can do this? We don't know. So we cannot write a program for a computer to do the same task. Instead of writing program, we provide the model with some examples, like I did for myself. I learn your face piece by piece, all right? So we provide our model with some examples, and we train this model on these examples. Once he learn these examples, he can predict for the future examples. Okay, let's say I'd like to make my model predict on the price for some houses. Okay, so what should I do? I should give him the input and output for these houses. I already know. What is the input? The input is some feature of the house, like how many number of rooms, how many number of floor, what is the area of this house, how old is this house, and the output, it will be the price. So I give him the feature and price. Your model will learn from this data. And then for the new, he will develop his own program. For the new data, just to give him the input, he will give you the output, which is the price. You got my point, guys? This is why we need machine learning. So what machine learning do? Machine learning learn from data. Learn from data. Correct, guys? All right. And we talk about three types of machines in our real life. Do you remember? Can you tell me? Regular machine, algorithmic machine, and intelligent machine. Remember? Forgot intelligent machine. Artificial intelligence. Okay, regular machine, guys, like the pen is regular machine, the cup is a regular machine, the window is a regular machine, the eyeglass regular machine. Your necklace is regular machine. A ring. It's just a machine. It doesn't have thinking inside. It's not a tool, right? But we have something else called the algorithmic machine. This algorithmic machine follow the steps to give you a correct answer. Give me example for this, guys. Calculator. Calculator is algorithmic machine. Calculator has steps inside the program inside. Okay, and I give the calculator the input, and with follow the steps through this program to give you the output. And example, I give 3 plus 5. The program in calculator is addition. Follow the steps and give you the output 8. Okay, guys, do you have any other example?
ATM machine.
Huh?
ATM machine.
ATM machine, good, very good. ATM machine follows the instructions and give you the correct answer. Thank you. This is very good. All right. Another example? Huh? What is? Addition. What is the program inside? I don't know. The remote, and give him the order and he change it.
Yeah.
But this remotely controlled, but I don't think there is algorithm inside. No. Algorithm, washing machine has algorithm. Washing machine steps, right? So anything you follow sequence of steps is called algorithm. Huh? ECG machine also is algorithmic machine. Washing machine, you give the input, your dirty clothes, and follow the steps. It has program inside and give you the output, which is clean clothes. Washing machine itself has no brain, right? No thinking, but follow the steps. Also, computer, guys, you can consider computer. This computer can handle it. No, it's hard, right? This computer, let me talk about my computer. Is algorithmic machine, right? I give him the input from here, and he has program inside, and he give me the output. Correct? I give him some data, and I he has summation programming, he give me summation as output. Correct? This algorithmic machine. What is the intelligent machine? What is the intelligent machine? We have three types of machine. What is the third type? The intelligent machine.
Human.
The human, us, intelligent machine. We learn. We don't need somebody to write a program for us. We develop our own programs. We learn from examples, from data. We develop our own programs. You get this? That's what we try to make our computer. We try to make our computer not just algorithmic machine, but intelligent machine. We try to make our computer develop its own program. How come? I give him the input and I give him the output. And he learns from this data and he produces his own program. For the new input, he will use this program to give me the new output. Same example. We have, I provide my model here, my computer, with the input, the feature of the houses, the output, the prices of the houses. He developed his own program. He learned from this data. Okay? So the output, he give him input and output, but he produced the program. Later, for the new house, I give him the feature of the house, and he'll give me the price, the output. Got this, guys? All right. Now, we also talk about how many types of learning. Remember learning? How many types of learning we have? Three, yeah. Supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we provide our model with what in supervised learning? With the input and the output, both. But unsupervised learning, we provide our model with only input because we don't have output for this. Okay. All right. Like what? Like give him the input and he cluster, he explore the data and group the similar data together. Correct? Put it in same cluster. So once you ask about what of this cluster can provide you with the data of all clusters for the whole cluster. Okay, guys? That's what we call it. We call it unsupervised learning because we provide our model with just the input. We don't have an output. And he didn't need output. And we don't have output. So he clustered the data. He tell you this group and this group and this group. Okay? And the last one is reinforcement learning. And in this learning, we try to teach our model to react to any change in the environment. Can you give me example, guys? The drones, the autonomous drones. Which one? The drones you use the remote control to control it. It's not intelligent machine, but the one he can decide itself and it navigate by itself. Okay, so autonomous drone. It could be reinforcement learning. What else? Self-driving car, of course. Each time the driving car look for the environment, take a decision. Environment change, take another decision, and so on. Okay, one man pass through on the front of it, so take decision and stop before killing them. Okay, and so on. Okay, so also, guys, games like chess, how when you play games with the computer. So this reinforcement learning, you can react according to the change you made. Okay, guys, this reinforcement learning. In this course, guys, I told you we just care about now what you care about. Supervised learning. We have two types of supervised learning: classification and regression. In classification, we try to predict for any new input which class he belongs to, this class or this class. But in regression, we try to predict for the new input what is the specific value. Example, if I have a symptoms for some patient and I try to decide what's the good drugs for them. Okay, so or they have this sickness or not? What is the good drugs for them? This classification problem. Right? In regression, if you try to find the price of the house, you need not just to tell me 1 and 0. No, you tell me what the price. Okay? If I'm trying to predict for tomorrow if it will be hot or cold, what this problem would be? Classification, hot or cold. But if I ask you, what is the temperature degree tomorrow? This regression right away. Correct, guys? The second one, let me give you another example, another question. If I'm trying to predict for some student if he will be fail or success. Succeed. Succeed. What is classification? But if I'm trying to predict what is the specific grade he will get, what is specific mark he will get, this regression. So this guys, if I'm trying to predict of this person, he will be my employee or not in my will not my employee. This classification. But if I'm trying to predict his salary, calculated, all right. So this will be regression. Okay, guys, we cover all this. So come here. We cover this, guys, huh? Look at it. We cover all this. Did we talk about this?
Yes.
Let's talk about this and this type of regression and classification. And I will stop here for 1 second. But this, guys, accuracy and interpretability. What the accuracy and interpretability means? Accuracy means if your model accurate and can predict the correct output or not. All right? If your model accurate and can predict the correct output or not. Okay, what's the interpretability? If we can understand why he chose this option or not, or cannot understand it. If we could understand and explain why your machine learning decide this option, so it's called the interpretability. We can interpret, we can explain why. All right. If we have a very simple method, very simple model, I'm trying to predict the house price according to one feature, very simple, according to the number of rooms. So this will be interpretable. Why? Because if I have high price, and they tell me why high price, I will tell you because the number of rooms is high. If I got low price, it will ask me why, because the number of rooms is low. So this it's easy to interpret, but actually, one feature is not enough to get accurate price. You think that? No. If I say I have a house of 3 rooms, can you tell me the price? Many things you need to learn. How many floor? How many bathroom? How old is this house? How far this house from city center? So he will not. Your model cannot give you an accurate answer. So even simple method is very interpretable, but it is not accurate. Okay, so what we need, simple method is not enough. Add some more complexity to your method. Complexity means I add some more feature. I will consider the number of floors, the age of the house, how far the house from city center, if the house is furnished or not. Correct, guys? Many things you need. If it has swimming pool or not, have heating system or not, have air condition or not. Many things you need to. How big the garage? How many car could be in the garage? All right. So if I have this, if I add all these features, maybe I will get a good accuracy. So I will get accuracy for the price. You would ask for many things so you can decide the price. All right. But when you give me the price, I cannot explain which one of these features responsible for this price. Okay, guys, it is hard to interpret. Okay, guys, you got my point? So if we have high accuracy, this will be less interpretability. And if you have high interpretability, you get less accuracy. I have a question. If I have simple method, simple model, this high accuracy or low accuracy, one simple model. Simple model, one simple, depend on one feature.
Less accuracy.
Less accuracy, but high interpretability. Can I explain any result? If I have complex model, accuracy, but less interpretability. That's what I'm trying to say. A simple method produce a model is easy to interpret, to explain, but less accurate. Okay? Because accuracy concerned about the ability of your model to make correct prediction, give you correct prediction. But interpretability, tell me what degree of model can allow human understanding would be explained. All right. The accurate model is more complex. Okay, guys. Simple model is less accurate, but accurate model is more complex, and interpretable model less accurate. Okay, guys. So if you were in this position for take decision, all right, which one you go with, high accuracy or high interpretability? High interpretability and predict all the time wrong. So high interpretability and print, yeah. So this less accuracy. So you will predict all your data wrong. What's the point of machine learning? High accuracy, right? Most of time high accuracy. Most of time, not all of time. I will tell you why. If you are a doctor and you try to find out about the sickness of your patient, all right. So you need high accuracy to give him the correct drug, right? But correct treatment, all right. But you didn't need to explain everything to him. Okay, you don't need this. So interpretability is not big deal, but accuracy is big deal. But let's say you are work at the bank and you are responsible to assess the application of loan. You know the application? So or somebody apply for the loan and you try to take, yeah, this person, I will grant him the loan, and this person, I will deny his application, right? I will decline his application. All right. So in this case, if you take a decision, you need to write a report. You need to explain what's the decision. So if you have a decision, if you have a decision model or machine learning, a high accuracy, you cannot explain what the result come from. So we need to sacrifice. You know what sacrifice means? Give up, all right, some of the accuracy for the sake of interpretability. But most of time we need accurate model. But for some cases, we need interpretable model. You got this, guys? Now you understand we have two things against each other, and we need to trade off between them, interpretability and accuracy. Okay, guys? All right. Now I will stop for 1 second here, and I will share my screen with you. And I will make whiteboard. How to make whiteboard? I make whiteboard. This whiteboard. Okay, nice whiteboard. Let me ask you a question, you guys. If I have model and of course a model training set and test set, okay? And let's say my training set accuracy equal 45%. Okay, train. Where?
NING.
So what should I take off? Okay. 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 We should delete it and rewrite it again, right? All right, training. And testing set, guys. Give me accuracy 35%. Can you tell me what is the error in training set? 55. He got 45 of the data correct, and so he got 55 of the data wrong. Is this the error in training set? We call this error, guys, bias. So here, the bias, what the bias equal, guys? 55%. This is the error in training set. All right, testing set now is 35. Can you tell me what the error in test set? So the variance is the error. Is it how many? 65%. Okay, so it is very bad model. Okay, guys, very bad model. Why we make it, we call it very bad model? Because it is high in bias, high in variance. What is a bias again? The error in training set. And what is the variance? The error in test set. You know what means? What means high in bias? That means your model didn't learn yet, haven't learned yet. He can't fit the data, understand the data. That's why you call this situation, guys, underfitting. Underfitting. He didn't fit yet. So if you're asking me what's the underfitting, I would tell you if we have high bias, high variance. What's the high bias? The error in training set. What is the variance? The variance? The error in test set. If you have high bias, means that your model didn't learn yet. If you have high variance, that means your model cannot predict. You get high error in prediction for the new data. You got this, guys? So this model is very bad model. Okay. If I have another model, guys, right? This model, the training, accuracy give me 99%. And testing, accuracy give me 35%, 38%. Okay, can you tell me what is the bias here? So the bias equal 1%. Very good model, right? And what is the variance? 62%. Do you think it is good model? This is very bad model, guys. Why? Because even he give you high accuracy in training set, but you cannot give it to the people to use. Because for any unseen data he never seen before, they give you this bad accuracy and give you this high variance. This model, guys, he just understand the training set. He's just good with the training set. He memorize it, not understand it. He memorize the data set, the training set. So this model, guys, it is high variance, no, low variance. So sorry, low bias, but high variance. Low bias and high variance, we call it overfitting. Overfitting, yes. Why? Because he just very good with the training set. He memorized the training set, but he cannot predict according to what he learned. Okay, he cannot predict. So it's called overfitting. He just any change, he's sensitive to this data set. Any changes in the data in training set, he cannot give you a good accuracy. You got this, guys? So which one you like more? Both bad. Both bad. Okay. But actually, the first one you are not responsible for. Why the first one you are not responsible for? Can you tell me why? Because underfitting come from very simple model. Very simple model, guys. Always give you bad accuracy in training set. Like what? Like I'm trying to predict the house price based on just a number of rooms. So the data said 3 rooms, 3 rooms, 3 bedrooms a house, 3 bedrooms a house, all right? 100,000 euro. 3 bedrooms a house, 150,000 euro. 3 bedrooms a house, 200,000 euro. Why? Because there is many features you didn't mention here. So your model will not learn. Okay, guys, your model will not learn. So this is underfitting. Why? Because the data is not enough. So if you got underfitting, nobody can blame you for this because the data is not enough. But overfitting, that means you have enough data, but you don't know how to handle this data. So the things come from the training set can give you 99%, but test set give you bad accuracy. Let me ask you another question. If the training set accuracy, give you 85%, and test set accuracy testing give you 79%. Do you like this? I like this. Why? Can you tell me what the bias here?
15.
Bias equal 15%, and variance equal
21.
21%. This, guys, we can call it low bias and low variance. And this model is fit. Optimal model. Very good model. Okay, guys? So don't be happy with the training set with the high accuracy. Don't be happy. Because maybe this overfitting. I got training set accuracy 100%. The bias equals 0. I don't have any error in training set. Calm down. Okay. Maybe the variance give you very high, and your model just memorize your data. I don't understand how model can memorize your data. Let me tell you this. If you have, you told me if you have one feature, so I cannot predict correctly, and this underfitting. If we add more feature now, I add number of rooms, number of floors, the area of the house, the area of the garage, many feature, good feature. And we add some irrelevant feature. I add the name of the owner. The name of the owner. So your model will learn the awesome the house equal 100,000 euros. And golf house 150,000 euros. Do we see a house 200,000 euros? You will learn this. So if you ask again for the same data, it will give you correct answer. But for test set, Maxime house, he given the name Maxime. He never seen Maxime before. So he will not get a good accuracy. You understand, guys, how the overfitting happened? When you add some more feature, and this feature could be a relevant feature or dependent feature. We'll talk about this. Okay, guys? So in these cases, guys, don't go with the overfitting. And you need to learn overfitting. It's our big problem as a machine learning engineer. You would blamed for this, but nobody can blame you for underfitting, because underfitting may be lack of the data, lack of the features. Okay, but overfitting, that means you have enough data, but you don't know how to handle the data correctly. You got this, guys? So what the best thing we have, if we have high bias, high variance, of course, no. If both error high, low bias, high variance, overfitting, but low bias, low variance. And this better, way better than this. Okay, guys, this one, you cannot give it to anybody to use because it's bad accuracy in prediction for the new data. But this one can predict correctly most of the time. Okay, guys? All right. So do you need to read this one? This page? Page, what the page is called?
अपने मॉडल और फिटिंग हो जाएगी गलत है दो
Okay. Let me show you now the same information in formal way. Can you read with me, guys? Bias and variance. What's the bias, guys? What's the bias? What is the variance? What the training error say? This means your data not fit well. They learn. What the testing error means? The predictor new data or not. Okay, bias, systematic error, come from inability of model to learn the relationship between the input and output. This training set, and we call it. What's the variance? A random error comes from sensitivity of the small variation. They just memorize the training set. In exchange for new data, they cannot go. All right. So this called because it's sensitive because algorithm model noise in the training data. What's the noise? The feature we don't need. Okay. All right. Look here, guys, for this. For this one on the left-hand side. This left. This right. This right. Huh? Right for you. This right-hand side. This underfitting. Many big errors, right? Look at the one here. This overfitting, he got everything correctly in training set. Okay. But this here, the optimal solution. That's it. Okay. Also, this classification, this one now, we're trying to classify between two classes, the green dots and the purple stars. Okay. We still have many errors, right? We think, guys, that this one green. We think this green. We think this green. We think this green. We think this green. And we think this is purple. Think this is purple. Okay, guys, there's many errors. So these guys, high bias, high variance. High bias, high variance. This underfitting. Why? Because high bias, high in training error, and high variance, high test errors. The other hand, the other one here. Look here, guys, for this. Always give you the correct answer, exactly correct answer. They differentiate between them 100%. But be careful. This low bias, but high variance. High variance give me over. You got this, guys? Of course, guys, high bias give you high variance. High bias always give you high variance because your model didn't fit yet, didn't learn yet, so he cannot predict. Okay? High bias give you always high value. Okay? So here we understand this part. Let me tell you, if you are a manager of company, not developer, and you will receive one model, one machine learning model, what should you do to make sure the model is correct? The first thing, to test your model. If it is perform good in your test set, this good model. If you got low variance, correct, this is good model. But if it is high variance and not good with the test set, I will go back to the training set. If it is good with the training set, this is overfitting because high accuracy in training set and bad accuracy in test set. Low bias and high variance. But if it is bad also in training set, you should fire this engineer. Okay, because it is bad in training set and he knows, all right, and give it to you to test it. All right, okay. So this underfitting because this low bias and low value. Oh, sorry, high bias, high variance. Bad accuracy in training set and bad accuracy in testing. Got it? Okay. Now look here for this. Let's say I have a model with one feature. Very simple model with one feature. Look about how bad it is. The accuracy now is one feature. Okay, it's one feature. One feature. Look here, guys, at the error of training, which is bias, very high. Because not only the number of rooms only not enough to predict the house price. Correct, guys?
Yes.
Also, guys, if you have a patient and you have multiple symptoms, not just one symptom, can you tell you what the illness he has? Okay? All right. So this is bad thing, right? But we keep adding more feature. I can add number of floors. I can add the area of the house, the number. So look here at the arrow, guys. The arrow getting down, down. Maybe close to zero. I keep adding feature. The complexity has increased. Okay. But on the other hand, look at the red one, which is variance. Okay, guys. When you have a simple model, the variance is very bad. Okay. Very high error. And when you keep adding feature, the variance gets lower. until a specific point. When you add feature not relevant, or your feature will be so huge, here's of the dimensionality. Okay. So what happened? The error getting increase. All right. So my question to you now, in this case, guys, this overfitting or underfitting? Underfitting, high bias, high variance. And in this case, guys, overfitting, right? Overfitting, because low bias, but keep enhancing the training set, but on the other hand, the test set get good worse, right? The accuracy in tests. All right. Why? Because if you come here, okay, let's see here. Look here, guys. This high variance, high bias. Okay, and this one low bias, but high variance. Correct, guys? What's the best? What's the best scenario here, guys? What's the best scenario here? This one. Okay, this is the optimal point. This is the best scenario. This low bias and low variance. Look, this low bias and low variance. I mean this low bias and low. Okay, guys, you got this? So we understand the connection between the bias and variance and the trade-off between them. Don't be happy with the accuracy of training set 100%. Look for the variance. Okay, now we understand now clearly, guys, that our problem not with the underfitting, our problem with the overfitting. From now on, guys, when you learn the machine learning, put overfitting in your mind. When you prepare your data, overfitting. When you design your model, overfitting. When you test your model, overfitting. You're afraid from overfitting all the time. So how can we detect the overfitting? How to know what the part of data makes this overfitting? All right. How can you do this? Look here, guys. There is a method is called key fold. What the key fold means? That means if this is your data set, I divide my data set to equal folds, equal portions, equal parts. Each part I will call it fold. So in this case, I have 1, 2, 3, 4, 5. This 5-fold. In this case, guys, what I'm having here, 5-fold. Correct, guys? When I train my model, I make iteration, train 1, train 2, iteration 1, iteration 2, iteration 3, I keep doing this. In the first iteration, take the first fold as a test and the rest of them as a training. Okay? Okay, guys? In the second iteration, take the second one and the rest of them as a iteration. In the third iteration, take the third one as a test and the rest of them as a iteration. In the fourth iteration, the fourth one as a test as a training. And the fifth iteration, take the fifth one as a test and the rest of them as a training. In the sixth one, take the first one as a test and the rest of them as a iteration, as a training, and keep doing this. You got this? Let's say, guys, I have this result. I find this accuracy 53%. Accuracy of the test set. And here 91%. And here 94. Okay. Okay. And this one is 52%. Right? And this 55%. You know what that means? That means your model overfitting in this part of data. You memorize this part. Okay. Why? Because if it is good model, he will give you similar number for each part. So if I get 90, 91, 92, 90, so it is good model. But actually, one part give me high accuracy and the other part is give me bad accuracy or regular medium accuracy. That means this model is overfitting in this node. Okay, guys? So don't trust. If I were you, I will take this part out of my data and I keep training my model. Okay? This method, guys, is called k-fold. And it's called also cross-validation because I validate my model. Validate means test my model in this part first, and second part, and third part. And I'm going cross all my data set to validate my model. Cross-validation. And cross-validation has this abbreviation, CV. So when we talk about CV, we don't talk about your CV. Okay, we talk about cross-validation, which is called k-fold. K-fold or cross-validation or k-fold cross-validation, same thing like CV. Okay, guys? All right. What is a cross-validation again? Does it work? Cross-validation is one of the most valuable technique to detect the overfitting, to know where exactly the overfitting. We split the data set, data point, into k equally sized subset, into 5, into 10, into 6, matter of trial and error. Okay? And we call it faults, each one. One split subset act as a testing set, and the remaining faults will train the model. Do you understand, guys? So now we learn how to detect the overfitting. Now, can you tell me how to avoid and prevent the overfitting? Many methods to do this. Okay. The first one, how to prevent or to expand the data set. If you have small number of data point,
You have to.
he will memorize it. So expand it, so your model will be happy. He will not be able to memorize it. You try to understand it. Okay, guys? Expand the data set. Collect more observation. Have some more examples, more rows. Static, not feature, more rows. Okay, so he cannot memorize the whole data. Okay. Second thing, achieve optimal level by stopping early. Don't go all the way. Remember when you go all the way, the bias go down and the variance go up. So find the correct point to stop early. Okay, we can teach you later how to stop early. You guys? Data augmentation. Data augmentation means we add more data, but artificial data, like we do with the smooth. All right? Can you tell me what the smooth means? Smooth stands for? Synthetic and minority oversampling technique. So we add some fake data. This is data augmentation. If we don't have enough real data, say expand your data set. You know what's expand your data set? That means to go to business again to ask them again for data set. Remember when we talk about the lifetime of machine learning? CRISP, right? In the CRISP, if we test our model and they give me bad accuracy, I'll go to business understanding again, right? So we need to expand our data set again. Something missing. Okay? All right, but data augmentation, we create some artificial data, like using smooth. Okay? Model complexity. The model is very, very complex, is overfitting. Any model, guys, with number of features greater than 100 features, this overfitting right away. And all the time try to reduce this complexity. And we already did this last week with the breast cancer data set. Remember this? We have the way to make breast cancer data set 37 column, and we reduce this number of features to 22. Remember? So this is good to reduce the complexity, because many over complex model, all right, that give me overfitting. Okay, guys? All right. Now, what this cross validation again? You just tell me cross validation to detect the overfitting. How to prevent the overfitting? I will tell you. Look here, guys. Look here. Your model here, will be trained on different data each time. Not totally different, but slightly different. Look at the first iteration and second iteration. You will find the first and second and third same, but fourth and fifth is different, right? So your model will not get a chance to memorize the date because each time you will see a new date. So this how to avoid the overfitting. So we learn a new thing now. This cross validation is a good way to detect the overfitting and a good way to prevent the overfitting. Okay, guys? When we find the accuracy is higher than the others, I learned these some overfitting. And I will do cross validation to avoid overfitting all the time. So I will not give a chance to my model to memorize a specific part of the data. Okay? I will not depend on one split, just split. I should do it all of them. Okay, guys? So cross validation is a good thing, a good method to prevent overfitting. Why? Because your model will be trained on a slightly different data set each time. Okay, guys? Feature selection. Do you remember this term, feature selection in data preparation? In feature selection, we remove irrelevant feature, like the name of the owners. Okay? Because there's the name of the owner make trouble because make overfitting. Irrelevant feature and dependent feature. We reduce them together to reduce the number of feature, to reduce the complexity, to avoid overfitting. You understand this, guys? Perfect, guys. Now I'm sure you understand what this. We talk about curse of dimensionality before. We learned before this high dimensional data set, the data with many features. Any data set greater than 100 features called the high dimensional data set. And increasing the dimensionality of data set and make two problems. The first problem, it is hard to train. Second problem, overfitting. Okay, because many number of features give me overfitting. All right, guys? It doesn't give you good accuracy in test set. So here, guys, dimension of data set means number of attributes or feature or column. Okay? Data set, large data set. This means generally the order of data set more than 100. Okay? 100 or more. This high dimensional data set. High dimensional data set come with some difficulties. What the difficulty? It's hard to train. And second thing, it is give you bad accuracy. What the bad accuracy? The curse of dimensionality means error increase the bias, guys. I mean here the bias increase with the increase of number of features. Correct, guys? So curse of dimensionality means what that means. Curse of dimensionality means a high dimensional data set brings two problems. The first problem is hard to train and brings overfitting. What the overfitting, guys? High accuracy in training set and bad accuracy in test. Low bias and high variance. 100%? Okay. We got this, guys? These guys, the concept you should put it in mind all the time when you develop your models. We talk about what is the type of machines. We talk about why do we need, what the problem exactly we need machine learning for. We talk about how many types of learning. We learn what the difference between classification and regression. We learn the trade-off between interpretability and accuracy. We learn what is the bias means, what is the variance means, what is the overfitting means, what is the underfitting means. Okay, guys? We learn how to detect the overfitting, cross validation, how to prevent the overfitting. All right? And we learn the concept of curse of dimensionality. Put this in your mind during any model you will try to develop in the future. Okay? Do you have a question? And we take how many minutes we need for rest? 2?
Yeah.
What? 3?
No, I saw someone.
Really, you
No, I saw someone say 10. I saw someone raise their fingers to say 10. I want to think.
Okay, 10 minutes. Okay, 10 minutes, and we'll be back. The time now is 4:14. We start back. All right. See you in 10 minutes. Welcome.
Sampai na rin ba tayo? Hindi ka po. Nag-turn ko.
ഭയങ്കരമായിട്ട് ഉറക്കം വരുന്നു ഇതൊന്ന്
ഇങ്ങനെ പോയത് മോളി നോക്കുന്നുണ്ടോ?
നല്ല വ്യൂ ആണ്
आपल्याला आधी कसं आपण डेटा प्रिपरेशन वगैरे चांगलं नाही. मेरा केस उसको बोला तो उसमें क्या बोला
मैंने बोला मैंने मैसेज कर दिया था सर
हाँ
कुछ नहीं बोले था सर
आया नंबर
हाँ मिल गया ना।
मिल गया फाइनली नाइस. प्रैक्टिस ही करते रहे. असं तर मग तुला विचारलं कॉम्प्युटर सांगशील मग मग त्याला माहित नाही ना तू काय വിഷൻ കേൾക്കുന്നു ഇതില്ലേ നമ്മള് നാളെ വെക്കണ്ട तो वो मेरे को समझ नहीं आया मेरे को कर समझा ही नहीं किसको कर रहा था मैं तो देख रहा था उस टाइम मैं तो देख रहा था देख कर दूसरा त्याला गेलेले लोगों लक्ष नव्हतं त्याकडे असं केलं काय इथे समजा काय करतात हाँ उसको करने का नहीं रे भाई लक्ष्य तो बायोटेक SAP ते आपली माहिती आहे काय तेच ना याच्यात टाकले जस्ट दाखवायला की इथून लई नाही भेटतो रॅन्डम त्याला 7-8 आणि त्याला तो मुद्दाम साठी असं आहे
പ്രാക്ടീസിങ് നോക്കുക കേട്ടോ
मस्त मौसम है क्लाउड दिखाता हूँ तुम्हें दुआ अरे दुआ मत दिखाना यार थोड़ा फिर वो म्हणजे पण त्याचं सजेस्ट करून त्याच्या पुढे लक्ष दे कारण त्याची इथं दिली तुला काही कॉर्नर लागत काही तो तुला सगळं झिरो पासून सांगतो त्याच्याकडे सपोज तू एक स्टेप मी जल्दी गेला ना तुला सांगेल काय थांबतो तो बरं आहे तो पायथन बिथन मला सारखा नाही तुला नाही काढलं तर आम्ही पण येतो तो पण तू ट्राय कर तरच सेक्शन होईल नाही घे तो असाइनमेंट सबमिट करायला लावतो मी तुझे करायला होतं तेच सबमिट करा एकच लेक्चर केलंय हा एकच आहे तेवढेच इधर भूख लगे निकल दुखली चार पाच गेले ना हम लोग खा के जाए भाई कल गए थे नहीं नहीं हाँ तो भैया को बोला मैंने हम गए थे वो बोलते थे एप्पल स्टोर में स्टूडेंट डिस्काउंट एप्पल स्टोर में जाके देखते हैं चार्विस के भाई सिटी सेंटर में ही है जाते पैदल ही जाते हैं फिर अपनी घर से नाही आपल्यापेक्षा स्वस्त आहे भाई काल करेज पण आम्ही गेलो आपले 10,000 स्वस्त आहे काल बघितलं पण 1,12,000 आहे कोणता रो 12,000 आहे 16 आणि ते 91
This really helps.
I'm looking so you should choose down that.
हिने बघितलं कुठे बघितलंय प्राइजेस Amazon
Oh, they're gonna be still recording.
Amazon नाही का रेकॉर्ड बोललेलो मराठीत बोललेलो काय बोललो पण मी इकडे येत होतात आपण ठीक आहे त्याला थोडं घेणार आहे आपण काही विचिंग नाही घेणार अरे तुझे आवडे ते ऑलरेडी इम्प्लिमेंट झाले अरे हा तुला हे दाखवायचं होतं ना कार्ड नाही पाहिलं का पाहिलं हा येईल ना माझा आता काय ते नंबर कार्डचं काही घेणं नाही तो नंबर आला की संपला विषय पहिला नाही मी टी शर्ट वर आलो काय तेवढं तर आहे रे आमचं काहीच नाही टेन्शन घेतोय काहीतरी परवडत नाही 80 रुपये कुठं चांगला आहे जिम 35 रुपये तू त्याच्यात सोसायटीत त्याला फ्री भेटेल आहे मला फॉर्म मध्ये जाशील तिकडे जिम होती अप्रोच केले अच्छा ठीक आहे लवकर अभी करवाएंगे थियरी हो गया अभी प्रैक्टिकल
You have 2 minutes. Yeah.
ठीक है ना फिर जल्दी आना था ना तो टाइम पे आई ना इसलिए हाँ है ना भाई मैं एवढं केलं तो काही प्रश्न करता तुम्ही काय बोलताय मला शिवाय नाही द्यायच्या तुम्हाला कुठून आणलं काय आता नाही समजलं हे काय करू तुम्हाला रिमाइंडर देतो रोज व्हायचं आता काय बोलू मी
उसको काम दे दिए हो
अरे वो पूछ रहे
तो आज से फोन में रिमाइंडर सेट जस्ट टेस्ट कर
अभी यही बोले उसको आज सुबह वो थोड़ा सा एंग्जियस हो रहा है रात को सोचने की भाई बट अच्छा क्या बात है तुमको समझ में सवाल उसने किए मेरे पे रहे तुम लोग मतलब अलग ही वही वी कैन अंडरस्टैंड ना उतना तो अपन दोस्त के लिए कर ही सकते हैं बस
कुछ भी प्रॉब्लम है तो उसको भी कॉल कर
जरूर जरूर सबको ग्रुप पे डाल दो बस
फोटो उठा लेगा
क्या डाल देते हैं अरे भाई इसका तो तीसरा चल रहा है
पंकज देख पे
इधर है अपना ग्रुप ये पागल है इस पे बोला है अरे अभी भी डाल रहे वो फॉर्म में आ रहा है इधर कुछ फिक्स भी नहीं तेरा अलग ही वहां जाके पता चल गया सबसे शॉक हो जाएंगे इनका क्या चल रहा है अगर मैंने डाला
I'm happy with it.
मैं तो डालने वाली
Because you're Empty.
പഠിക്കാനായിട്ട് अरे पेपरला कोर्स
वहां जाके पता चल गया पूरा फिर अब शमन तो क्या है फिर
तो कोर्स होता है
मारने को तुझे यार
क्या नाम है डीबीसी ला
वो तो है देखो ऐसा
Okay, folks, let's get back to work.
यस ऐसा मैनेजर चाहिए
Guys, today I will introduce you to the first model in machine learning. This is our first model. I think this the time we were waiting for study the first model. This model, guys, is supervised learning and it is classification model. Okay, so it's called the decision tree. Decision tree. Decision tree. So I have the tree, and this tree can help me to take a decision. All right? You finish? Okay. All right. So what is the decision tree is? Decision tree, guys, is a tree like. Tree like means look like tree, but upside down. Okay. So this is the root, and these leaves. Have you seen tree like this before? You seen road like this? Where? The leaves down there? I don't think so. I don't believe you. Okay. So this guy is called decision tree. Tree-like. Okay. Looks like tree. Contains nodes. This is called the nodes. Node, and branches. And this branches we can call it edges. Edges, right? This one, this node, guys, is the root of all nodes. This one, the big one, the highest one, is the root. And this is the leaves. Okay. Root, this nodes and edges. Each node, guys, has a test or has a question. And each branch or edge here has an answer. Now we need to know how to work with this decision tree. Let me give you example. Again, if you are work in the bank and you are responsible to assess the application for loans, all right? So you can decline the loan or you can accept and grant the loan, all right? So this decision tree can make. Let's say you have this applicant, this person, apply for the loan, okay? And you have this decision tree. What should you do? You should come here in the root and ask the first question. Is he a student? What's your answer according to this data? No. Which branch I should go, left or right? Okay. All right, left. So I go no. The question is, what's his income? What's his income, guys? Medium, left or right? Right branch. What's his credit record? Where, which branch, which way it's left? And what's his age? Less than or equal 40 or greater than 40?
greater than
Greater than 40. So what's your decision?
yes
So your decision here is yes. So you got it. Take a decision, and then you will give him the loan. Okay. Let me do another example. The other applicant over there. Okay. I would ask the same question. Is he student?
yes
Yes. Which way you wanna go? Right. Okay. What's his income?
no income
Low income. So
left
left. What's his credit record?
excellent
Excellent. We go
right
right. What's his age? Greater than 25 or less than 25? Greater than. So what's your decision? No. So we will not get it. Got it, guys? Now we answer two questions. The first question, what is a decision tree? Was second question, how you work with the decision tree? How decision tree works. The first question again, what is a decision tree? Decision tree is a tree like, contains of nodes and branches. Each node has a test, has a question, and each branch or edge has an answer. You got this, guys? Perfect. How to work with the decision tree? We start with the root and keep going, asking the question and answer until we reach to the decision at the leaves. Correct, guys? Again, decision tree is a tree-like model that illustrates a series of events leading to certain decision. Each node represents a test, a question of an attribute, and each branch is outcomes, the answer of this test. Easy, guys? All right. Now, I'm sure you're in mind now where decision trees come from. Okay? Decision trees come from data set. How? I will show you another data set, and I will show you the corresponding decision tree for this data set. This data set over there, and this decision tree for this decision tree for this data set. This data set, guys, try to predict if today is good day to play tennis or not. According to what is the outlook of the day, sunny or overcast or rain, what's the temperature, what's the humidity, what's the wind, to finally decide to play tennis or not. So this output feature, huh? This is output feature. Correct, guys? So if you look here for outlook, you will find the outlook is a name of the attribute. Correct, guys? And the answers here is values for this attribute, right? Correct, guys? Is values for this attribute. So this explains that where the decision tree come from. Come from data set. The nodes is attribute, and the edges is value of these attributes. Value. Correct, guys? This answers the question. But we didn't know yet how you build this decision tree from this data set. Correct? But at least we answered 3 questions. Okay. What the 3 questions again? What is a decision tree? How decision tree works? And where the decision tree come from? What is the decision tree, guys? Tree-like, right? Contains nodes and branches. Each node has a question, and each branch has answer. That's okay. How to work with the decision tree? We start from the root, and keep going until to reach to the decision at leaves. Okay, guys? The third question, where decision tree come from? Come from data set. The nodes is the attribute. And the edges here is the values of this attribute. Okay, look at this attribute, humidity. Right here. What is the value in humidity? High and normal. High and... But where the output here? Output is the decision. Okay, output not a question of our questions. Okay, I will not ask about play tennis or not. I'm trying to do all these things to answer, to see the correct output. So I'm asking about the input data to reach the decision here to the output data. Correct, guys? Now you need to learn how exactly I built this decision tree from this data set. Correct? Yeah, let's do this step by step. The first step, I will come here. I will take this outlook. Agree with me? So this outlook is supposed to be a node. Correct? Now, guys, can you tell me how many values here in the outlook? What are they? Can you tell me? Sunny, overcast, and rainy. Can we split this dataset to 3 different datasets according to this? Yes, let's do this together. I will come here and I will take the sunny by itself. Look, guys, sunny. This will be a dataset. I will take it out of the dataset and make the dataset by itself. And also, let's overcast, do overcast. This overcast. And do you see any other overcast here?
No.
Where? Below here. Okay. And then overcast is another data set by itself. Do we have any other data set? Rainy? Rainy. Okay. Set green. Not exactly, but okay. All right. How many data set we have now, guys? 3 data sets. Each one by itself. So at the same time, guys, here you should come here and tell me. So we have 3 answers, right? Sunny, overcast, and rainy, right? Okay, now it's good. But we don't have data set now. We have 3 different data sets. Correct? You want to see these data sets? Right there. Look, guys, see? 3 data sets. Right? I did this for you here. So I will come here. These 3 data sets. Guys, don't think this data set 4 column. This 5. Because the original data set is 5 column, right? But the column here, look at this column. This outlook here. This outlook here. But I find outlook equal sunny, 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 sunny. So I make it outlook equal sunny one time. You got this, guys? And here, what's the outlook here? Overcast, 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 overcast. Correct, guys? And what is the outlook here? Rainy, rainy. Rainy, rainy, rainy. Correct? You understand? So this is the 50 column, not 3 column. So this 3 part of it. So, and you understand how we built decision tree until this level. Okay. Now, if you look here for overcast, you will find the answer here all the time. Yes. So I can decide now. I can decide if it is overcast, go play tennis. Because whatever was the difference here in temperature and humidity, anyway, my decision is yes, go play tennis. So don't ask more information. What's the point? Correct, guys? So if the overcast, what should I put here, guys? What should I put here?
Yes.
Yes. I say go play tennis. Correct, guys? Why? Because they already decision could be made now. Because whatever was the change in the wind here sometimes weak and sometimes strong, the humidity high and normal, and hot and cold for temperature. Anyway, the decision is play tennis. So I can take decision, early decision here. But I cannot do this here or here. Correct, guys? I cannot do this. Why? Because this is still mix. I still need more information to decide. All right? The first data set and the third data set still mix. That's guys what we call this. We call this guys this data set. This one pure class. We call it pure class. But this not pure. Is this pure? Once you reach to pure class, you can take decision. But if it is not pure, cannot take decision. This state, guys, called the entropy. What the entropy means? Entropy means a mix. There's some randomness inside here. Entropy. Okay. This cup now is entropy. Let me see. It's entropy, guys. Because it is not just milk or just coffee. It is milk with coffee. The class here is entropy. Because the class here not all boys. If I had a class all boys, I would say pure class. If I had a class all girls, it's called pure class. But since you are mixed, that means entropy. You are entropy. Okay. Look, guys, if we have a class all boys, so the entropy equals 0. Because this pure class, the entropy equal 0. So if I take one boy out and replace it with one girl, now I have entropy, but not so much entropy still. I take another boy out and I put another girl, the entropy is higher now. And I keep taking one boy out and girl in. boy out and girl in, until entropy go to 0 again, because all of them will be girls. Invasion. Right. What we get? Correct? You understand the point? Can you tell me what is the point? We have highest entropy. You got it?
Then there will be equal amount.
Perfect. Perfect. When you could be 50-50. 50-50 is this highest. Again, this cup was milk. All right. And then the entropy equals 0. Okay. The guy, one guy went to the doctor and asked the doctor, he said, every time I drink coffee, my eyes hurt. The coffee said, take this out. The doctor said, take this out. Didn't get it. Didn't get it. All right. All right, guys. Now, if we have this all milk and I drop 1 drop of coffee and take 1 drop of milk out, so that the entropy starts now. Another drop of coffee and 1 milk out. Another drop of coffee and 1 milk out, until this all will be coffee. So in the first, when it was all milk, the entropy was equal 0. Correct? At the end for all coffee, the entropy equals 0. But the entropy keep increasing until certain point, keep decreasing to 0 again. What is certain point, guys? When we have the amount of coffee equal amount of milk. This 100% entropy. Okay, guys? All right. So here, guys, if you look here, guys, so we understand now we will not touch this data set because we already can take a decision. But this now, I need to split it again. And this one, I need to split it again. How to split it, guys? Second. How to split it? So let me choose, and I will tell you why I choose this later. Okay, let me choose here. For the first one, I will split the data set according to humidity. And this according to wind. I will explain this later. Okay, so according to humidity, guys, how many class we have? 2. What are they? High and normal. Let's now see high first. Okay, this data set, I can split it by itself. And then, of course, this will be a data set for normal by itself. Correct, guys? So I have data set to data set. And I understand also, the humidity have to answer high, correct, and normal. Correct, guys? I will not touch this because the decision already made. The other one, guys, can you tell me, according to wind, we have weak and strong. All right, let me do the strong. Okay. Huh? Right, guys? And the strong. And what is the weak? Let me see the weak. Another data set here. And another data set here. So how many data set here? 2. Correct, I divide them to 2. And the question here, the answer here will be weak.
Strong.
Correct? And strong. Horrible handwriting. Okay, you got it? Yeah. So what's the data set now look like? Let me see. Like this. I spread the data set here. Don't think this one, guys, is the 3 column. This 5. This 5. Look, guys, the overlook here, sunny, and the humidity here, normal. And this also 5. The outlook, sunny. The humidity, high. I remember high was 3. And this is 5. The overlook, rainy. And the wind, strong, right? And this was 5 also. The outlook, rainy, rainy, rainy. And the wind, weak, weak, weak. Okay, guys? So now we split our data set. Do we need more splitting or we already reached to pure classes? Where is this pure class?
Yes.
This pure class?
Yes.
This was pure class from the, this pure class?
Yes.
So this pure class?
Yes.
So I can take decision now for what data set. Okay, so can you help me with this? I'm going to ask you a question. If the outlook sunny and humidity high, what's your decision? This no? Well, yeah, this no.
He knows.
Correct. This no. Okay? Correct, guys? If the outlook is sunny and humidity is normal, what's your decision? Yes. If the outlook is overcast, what's your decision? Yes. Okay? If the outlook is rainy and wind is strong, what's your decision? Well, yeah, but then. Okay? If the outlook is rainy and wind is weak, what's your decision? So we could build this decision tree out of data set. How to do it? Keep splitting the data set until to reach
Yeah.
to pure classes. Pure classes. Entropy equals 0. You got this? And now we take a decision and they will be correct. Correct, guys? So we answer how many questions we answer now? 4. What first question?
What is the decision?
What is the decision tree? What the second question? How decision tree works? What the third question? Where decision tree came from? What the fourth question? How you build your decision tree? Okay, how you build your decision tree? Keep splitting data set until you reach to pure. I'm sure you had a question. Did you see? Did you see in the decision tree the temperature? No. Why? Temperature not important. It's look like this. It's not look like this. It is. We decide before we reach. We ask about temperature. Yeah. Okay. We decide before we look. We ask for temperature. But how I know in advance? I will not ask. This your data set right there. How I know in advance? I will not ask about temperature. This is a question, right? Why you choose outlook at the first one? Here, when you split the data set, why you choose humidity here and wind here? So choosing the attribute is the tricky part we need to learn. And this is a fixed question. What's the good attribute for splitting? Okay, so in this case, guys, I will show you a smaller data set. This data set, look at this data set, guys, this one. This data set, very small data set. Try just to differentiate between the mammals and birds. Just tell me if this animal is a mammal or a bird. Okay, according to just 2 attributes, to the color, or does it fly?
Does it fly?
Oh, yeah, you tell me that now. All right.
Mm.
So if I ask you what is the best splitting for data set, give me the many information. So I didn't need to ask many questions. So what is it? Which one is this? Does it work? Right? But let me start with the color. If it doesn't work, I will go with the flow. Okay? I will start with the color. Okay. So if I start with the color, I will split my data set according to the color. Could you tell me how many classes in the color here? What are they? Brown and white. So I will do this. I will do splitting data set according to this. This is a brown. Correct? What else brown? This brown. And this brown. Okay. And what is the other color? White. Okay. White. This white, correct? Okay. This how many data set we have now? 2. I imagine with me you split the data set to 2. Because I didn't draw it. So imagine with me we split the data set to 2. I'm asking you now, the white data set. See the white data set? It is pure.
No.
Why? because it's mammal, bird, mammal, bird. 50% mammals and 50% bird. Now this is the highest entropy ever. The entropy is equal 100%. Okay? All right. What about the other one, the brown data set? The brown data set. How many birds? 2. And how many mammals? 1. So 33% mammals and 60% birds. Also high entropy. Correct? So you were correct. I will not change and start with column. I will start with column. So I will take it back. I will delete everything now, and I will start with fly. So let's do this with fly and see what is the result. In the fly, guys, if I start with fly, how many class in the fly, guys?
2.
2. Yes and no. All right. So let's for now. Okay. How many? There's no fly. Correct, guys?
Yes.
There's no fly.
Also.
This correct?
Yes.
Okay. All right. What about the other data set? It's called yes? Yes. But the guys, so they do different data. This is not what data set I split it. Correct, guys? Split this data set. All right. Can you tell me for yes data set?
Yeah.
It is pure or not?
Yeah.
Yeah, bird. Yeah, 100%. You know how much entropy here?
0.
0%. Okay. Okay. What about the other data set, which we call it no? The other data set is called the no. What about this one? Mammal bird. So 75% of them. 75% of them mammals and 25% bird. Which one is more pure? Fly or color? Fly. So you were correct. The answer here, which attribute provide better splitting? What the better splitting means? Better splitting give me more information. I don't need to ask many questions. Okay? The one who give you pure class, less entropy, give you more information. More information, we call it information gain. The information we gain from this splitting. What we call it, guys? Information gain. Because it gives me more information. I don't need to ask many questions. You already enable me to decide early. To take decision early, right? All right. So which attribute provide better splitting? Because the result subset are more pure, like you said. Okay. Knowing the value of attribute give more information. What's the more information means? The entropy lower. Okay, guys. So high pure, high information gain, low entropy. Correct, guys? But if you have low pure, you get low information gain, but you get high entropy. You got this, guys? Again, can you tell me this again? High pure, this means high information gain. And information gain. And you got low entropy. Let's mix. But if you have low pure, like color, low pure, all right, that give you low information gain. You got small information gain, and you get high entropy. Okay, guys? All right. So we answer 5 questions. There is 1 question left for next one. But now, can you tell me what the 5 questions are? What is the decision tree? How to use the decision tree? Where decision tree come from? How to build the decision tree? How to choose the attribute? What's the good attribute? Okay. What is the decision tree, guys? Tree like nodes and branches. Each node has question, and each branch has answer. Correct. What the second question is? How to use decision tree? How to use decision tree? We start with root and keep answering the question until we reach to the decision at leaves. Correct? Where the decision tree come from? Data set. The attribute is a node. Correct? And branches is values in the attribute. Correct, guys? How you build your decision tree? How you build your decision tree? Keep, not split. Keep splitting. Not split one time. Keep splitting another until we reach to pure classes. Pure classes, you get the decision. How you choose the attribute? What's the best good attribute? High pure, high information gain, less entropy. Correct, guys? By the way, high pure equal high information gain equal less entropy. Okay, all right. But don't choose low pure, low information gain, high entropy. Okay, guys? All right. Actually, there's big question now you should ask. What exactly, how much amount of information I got from here and how much amount of information got from here? So you decide this better than this. We need number. That's why next time, guys, I will teach you how to calculate the information gain. Okay, guys? We need to calculate it to know how much information exactly I got from this splitting and how much information I got from the other splitting. So I decide fly better than color. Look here, guys. That's what we're gonna get. But this guy's information gain. The first thing I will teach you about information gain is entropy. Correct, guys? And then look, I give you the equation for information gain, and I come back to the same question. And I will teach you how to calculate the information gain. Looks the information gain come from color. Look at guys, 2%. And what is the information gain come from fly, guys? 52%. So you were correct. Right? This information gain gave me 52%, and this give me 2%. You were correct. And this is what we're gonna calculate next time. But before this, guys, can you tell me which one is high entropy, which one is low entropy? This is a high entropy because this makes this bad thing. But this low entropy. Okay? Supposed to be zero entropy, right?
Yes.
Maybe one strawberry back there. Back there. Okay. All right. So this low entropy. Look at this shape, guys. The entropy graph. If we have orange and apple, and 100% apple and 0% orange, that means the entropy equals zero. Orange and apple, 100% apple, all the basket apple, no orange, 0%. If I take one apple off, I put one orange, the entropy keep up, 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 up until 50-50. Look, guys, at 50-50, at 50-50, here, I just did it. Okay, like 50-50, 100% rate. 50-50, 100% rate. But the entropy keep down, down, down. I keep take apple out and orange in, apple out and orange in, until the whole basket became orange. So in this case, the orange 100% and apple 0%. The entropy come back to zero. Pure class again. So you understand what this graph is. Okay? You have any question? So I will upload this for you, and I'm asking you to read the lecture for Wednesday, and we don't have any assignment, just reading the lectures, both lecture studies. Okay? For you. Second. Guys, looking for the week, what's week?
Four.
Where is week 4?
Big four.
No, this. Come here. Guys, look here, guys, week 4. Where is the week 4? Here. You will find, I add picture for you here. What this picture said? Okay. We did this together, right? So I'll keep it for you here. Also, you will find the lecture of machine learning right here. Okay, this machine learning, the high dimensionality and stuff. But the new lecture, guys, I will upload it for week 5. Okay.
Yeah.
All right. So which one is the new? It's supposed to name it lecture 4. Not sure. Yeah. This is a new lecture here. Decision tree, guys. Got correct, guys? You will find it in week 5. Don't speak too much.
We will ask some questions.
Okay. Since you asked a question, forgive it. Let's see you next time.